Hi, my name is Philip and I will be presenting a third year project developed by Killian and myself. While working in the networking industry, we have seen that many common repetitive tasks are not automated. Some can be easily, however, many cases require custom software solutions. One of the largest solutions provider in this area is a company called SolarWinds. The devices we are targeting are high-end networking devices used in the industry applications, such as large businesses, universities and many other. The vendor of choice for us is Juniper, due to their reliability and cross-platform support. We have seen the biggest requirements for automation in three main areas: deployment of devices, from bare metal to being ready to be installed, storing and archiving configuration files of devices, as well as troubleshooting a network easily by mapping it out. We have decided to develop a platform that will address the main issues encountered in these three areas. Our target market will be small to medium-sized network companies, and the program will be used by network engineers. Some requirements include having a console, FTP and database server, as shown in this network diagram. However, this won't be an issue as the vast majority of network companies require such devices for day-to-day operation. Our application runs on the client side and utilizes the console, database and FTP server for various tasks. The configuration and operating system files required by these networking devices are stored on the FTP server. The console server is used in order to communicate with the device to be configured. And finally, the database server keeps track of the configured devices and stores configuration changes over time. This is an example of a very simple network setup required to utilize some of the functionality of our platform. At the top left is an entry-level switch used to interconnect all of the devices. Beside it, the little black box is a Raspberry Pi which is running an SQL and FTP server. When deployed in a real-world scenario, it will be replaced by a high-end server in order to avoid bottlenecks while deploying many devices at once. At the bottom is the console server required, and in this case we have decided to use the SRX 300 Juniper firewalls. They are entry-level firewalls and are running Junos, an operating system used by all Juniper devices. This ensures compatibility with the different switches, routers and firewalls offered by Juniper networks. And finally, the connections between these devices are shown. The installation is quite simple. Everything required is located in the installed folder. And firstly, you will have to run part 1 installation as administrator. Now this will install and download Python and some of the required tools such as pip. Similarly, for Linux devices, you will use the linux install.sh file in order to accomplish a similar task. And this might take a while to download and install, however, there's no user input required. It is quite straightforward, and when it finishes it will close down. Secondly, you will have to run part 2 as administrator. Now this will use pip in order to install the required dependencies for the program to execute correctly, such as PyMySQL, NetworkX, XML2Dict, PyQt5, etc. And when it finishes, again it will close down. In addition, the install folder will contain the schema for the database, which will be deployed and used by the engineer on their SQL server, which makes the whole process a lot easier and a lot more streamlined. When you initially start the application, you double click the launcher icon and you will be prompted by a settings screen. You enter the required FTP server address, FTP username, OS directory path, configuration path and initial configuration path. As we mentioned before, all of these devices have an operating system, and the config directory holds the configuration files of those devices, and the initial configuration directory holds the initial configuration files of these devices. Console server address is entered, as well as console server username, and database configuration field is populated by the database address and database username. Now when you start the launcher backup, you will be prompted with passwords for the database server as well as the FTP server, and on the bottom, as you can see, you can edit those settings if you want to change them in the future, if your network topology has changed. After you click login, you will be prompted with 3 options: deployment, maintenance and troubleshooting. In deployment, first you select your operating system for the device. Afterwards, you choose the first console port and then the last console port to be configured. You type in your initial device password as well as your console server password. In this case, we're cloning to backup partition and finally selecting the initial configuration file range, so from configuration file 1 to configuration file 2, as we are configuring only 2 devices. On the right hand side, after we click begin deployment, you will see us connecting to the device and a progress bar, and there's also a helper option that will allow you to see what each field requires you to input if you have any issue setting up your device. As mentioned before, each one of these devices has an operating system, Junos, which is stored on the FTP server, and we can select it from a drop-down menu from above. In our case, the console server has 4 ports and we're selecting from port 1 to port 2. There are console servers with 24 and 48 ports, which are much more common. The clone to backup partition option is there, as most of these devices have a primary and backup partition. So if the primary partition fails, the backup partition will take over, and by selecting clone to backup partition, we are basically saying that the operating system we're installing on the primary partition should be also installed on the backup partition. And finally, the configuration files are located on the FTP server as well, and they are listed sequentially. And in this case, you can see, as we are configuring only 2 devices, we selecting configuration file 1 to configuration file 2. They will hold all the necessary data in order to configure these devices, such as whether they will run DHCP, what kind of firewall rules they will have, etc., as I will demonstrate later on. And as you can see here on the right hand side, the progress bar is being updated. This video has been fast forwarded as the process can take up to 20 minutes to deploy a batch of devices. However, if you're configuring, for example, 10 devices at once, you have an efficiency of that is 10 times greater than if you were doing them manually. So if an engineer in a company is configuring a single device, it will take them up to 20 minutes, whereas in our case we are configuring 2 devices in the same time period without any input required from an engineer. The solution is entirely scalable, as you can configure up to as many devices as you want due to the nature of the program being multi-threaded, and the only limiting factor in this case will be your hardware infrastructure. So if your console server has 48 ports and your network switch has 48 ports and your server is able to handle the FTP and database traffic, you can configure up to as many devices as you can support. As you can see, the deployment of this batch has been successful, and this is indicated with the full progress bar and all the steps highlighted. You can reset the progress of the screen in order to deploy a new batch, as well as display a database that shows you the 2 devices that we have just configured. You can also see in this database that the name of the device is highlighted, as well as the serial number, the user that deployed them, timestamp, configuration path, the initial configuration, which is the title of the deployment, description, and as well as the boolean is current configuration. You can also export them to a CSV file viewable in Excel. Now we will log into this device manually in order to check whether our deployment has been successful. We will check whether the operating system has been successfully installed on the primary as well as the backup partition. As we can see, we selected the 60 primary and backup operating system, and it has been installed successfully. Now that is the configuration file we have set for the device. As you can see, the host name is SRX300-1, and we have set up a name server to be dcu.ie. And you can see there are many various things set here, such as TCP, ICMP traffic, policies for firewalls, zones, and DHCP and FTP rules, as well as the ports, each one of the ports on the front of the device. Finally, you can see that we extracted the SNMP location into the database, so we know that this is, for example, a school. The maintenance module is a GitHub-like feature of this platform, keeping track of configuration files. In this case, we will select a different configuration file for the SRX300-1 configuration. That's a device that we previously have configured and deployed. So in this case, we will just give it a commit title and a brief description. And as you can see here, we can compare what's been added to what's been removed from the configuration file, and we can add the configuration file to the database, and at this moment we will see two configuration files under SRX300-1, as you can see, with a timestamp and ordered chronologically. This is a very useful feature as it allows companies to keep track of which engineer uploaded which configuration file to the device, or if there has been an issue, it allows them to roll back to the previous configuration, much like GitHub does, and in addition it also allows you to see the current configuration file. So if a device goes down, for example, and cannot be accessed remotely, you know exactly which configuration file has been applied to the device, and easily being able to troubleshoot and see if the configuration file was at fault. Finally, the troubleshooting module allows the user to easily scan a network they're located on. This is a multi-threaded process, so it doesn't take very long to scan a network. Depending on the size of the network, it might take a few minutes for the network to get scanned. And as you can see here, it shows you a clear diagram of the network we're currently located on. The computer that's scanning the network is 192.168.0.55, an ASUS computer. A .5 represents our console server, and .136 is our Raspberry Pi on our local area network. And you can see some other devices such as Samsung device, Motorola device, etc. And now finally here we come to a Juniper Networks device. Now we can log into that device to gather more information from that device. We put in our username and our password into the device, and we get additional information that on that device, such as the CPU temperature, RAM usage, uptime, and whether there are any alarms currently on the device, whether there are any issues with the device at the moment. This is very useful as you do not need to log into the device manually, and it's quite simple to use. Here you can see that we can manipulate the network diagram as we choose, as well as being able to save the network diagram as an image for later use. And here we refresh the network diagram and go back to the main menu. To summarize, we have developed a network automation tool that supports Juniper Networks devices. It is aimed at network engineers and small and medium-sized networking companies. It improves network productivity and efficiency and tackles three main areas where we saw the most room for improvement. These are deployment of devices, maintenance of devices and their configurations, and troubleshooting of networks, which is scanning the networks. And this software has already been used to deploy over 200 devices around the country. Thank you.